Hello students, today we will see how the set of linear equations are solved in numerical techniques. The techniques and methods for solving system of linear algebraic equations belongs to two fundamental different approaches. In numerical techniques, we have two approaches to solve the set of linear equations. First is the elimination approach and the second is the iterative approach. In today's video, we will see the elimination approach. We will try to learn one of the elimination approach. So, elimination approach is also known as the direct method. It reduces the given set of equations to a form from which the solution can be obtained from simple substitution. Basically, there are number of approaches in elimination approach. So, like we have the basic Guass and we have the Guass elimination with pivoting and we have the Gauss-Jordan and we have the LU decomposition. So in this video we will take the Gauss elimination, or we can say the basic Gauss method, and we will try to check its algorithm, how the basic Gauss works. So basic Gauss, this method comprises of two phases. When we try to solve the set of linear equation using the basic Gauss, it has two phases. Phase first is the forward elimination phase and phase second is the back substitution. In forward elimination, we try to manipulate the equations in order to eliminate some unknowns and produce an upper triangular system. And in back substitution, we are just substituting the values in the reduced upper triangular system. So let's take an algorithm and try to understand it. So the algorithm for implementing Gauss elimination strategy is, like, say, suppose first of all we consider a general set of equations in n unknowns. So these are our set of equations. Say our equation number 1 is a11 xn plus a12 x2 plus a13 x3 up to a1n xn is equal to b1. Then we have the second equation as a21 x1 plus a22 x2 plus up to a2n xn, that is equal to b2. So we are taking these equations up to an1 x1 plus an2 x2 plus up to ann xn, that is equal to bn. So let us consider these are our set of equations for which we have to get the values of x1, x2, x3 likewise. So here we are given with the set of equations where we have the values up to xn. So if we have the variables up to xn, we will be having n number of equations. So the first thing is that we are considering these are our set of equations. Then the first step in it is we arrange these equations such that a11 is not equal to 0. So we are trying to first arrange these equations in an order that the constant of first term in the first equation will not be equivalent to 0. Then we eliminate the x1 from all equations but not from the first equations. Then we are trying to eliminate the x1. This variable x1, the term x1, we are trying to eliminate it from all the other equations but not from the first one. How we do that? We do that by first normalize the first equation by dividing it by a11. We first of all divide the first equation by a11, that is the constant with the first term in first equation. Then we subtract from the second equation a21 times the normalized first equation. If we do it, the result is a21 minus a21 a11 divided by a11 and x1 plus a22 minus a21 a12 divided by a11 x2 plus up to so on, that will be equivalent to b2 minus a21 b1 divided by a11. When we solve this set of equations, we will get the second equation as 0 plus a dash 22 x2 plus up to a dash 2n xn is equal to b dash 2. So that means we have just eliminated the values of x1 or the term x1 in the second equation. Similarly, we subtract from the third equation a31 times the normalized first equation. Then the result would be 0 a32 x2 plus up to a dash 3n xn is equal to b3 dash. So that means if we will continue this procedure up to the nth equation, then we will eliminate the values x1 from all the other equations but not from the. So if we repeat this process till the nth equation, our new form of equations will be a11 x1 plus a12 x2 plus up to so on a1n xn is equal to b1. Next equation will be a dash 22 x2 plus up to a dash 2n xn is equal to b dash 2, and so on up to a dash n2 x2 plus up to a dash nn xnn is equal to b dash n. That means we have eliminated x1 term from all the set of the equations except from the first one. So similarly, in the third step, what we have to do, we have to eliminate the value of x2 from all the other equations but not from the second one. So the procedure will continue as eliminate x2 from the third to the last equation in the new set. How we can achieve it directly? Like, we have to subtract from the third equation a32 divided by a dash 22 times the second equation, and in the fourth equation we have to subtract from the fourth equation a42 divided by a dash 22 times the second equations, and so on up to an. So we will thus get the new system of equations of type as a11 x1 plus a12 x2 plus a13 x3 up to a1n xn is equal to b1, a22 x2 plus a23 x3 plus up to a2n xn is equal to b2. And in the third equation, you see we have eliminated the term x2 from the third equation onwards. So it will be like a33 x3 plus up to a3n xn is equal to b3, and it will be up to a3n an plus up to ann xn is equal to b3. That means when we will follow the third step, it will eliminate the values or the term x2 from all the other equations except from the first one and the second one. So similarly, this process will continue till the last equation contains only one unknown xn. The final form of equations will look like this. That means this process is going to continue until the last term will contain only the first unknown. So this process is also known as the triangularization. See, now the new set of an equations, at last we will get it as a11 x1 plus a12 x2 plus a13 x3 plus up to a1n xn is equal to b1, a22 x2 plus a23 x3 plus up to a2n x3, that will be equal to b2. And in the third term, or the third equation, sorry, we will have the values from a33 x3 onwards. So in the last term or the last equation, we will be left with only one term, that will be ann xn is equal to bn. This process is known as triangularization because we have reduced the set of equations in a form of a triangle now. So with the in the last equation, we will be left with only one term, that will be ann xn is equal to bn. So somehow we have reduced it in the form of a triangle. So now we have to obtain the solution. How we can obtain the solution? We have to obtain the solution by backward substitution. What does that mean, backward substitution? So we have to obtain the solution by back substitution. Like say suppose here we have, in the last term we are left, in the last equation we are left with only one term, that is ann xn is equal to bn, which means that we can get the value of xn from the last term itself, and then we can substitute that xn value in the n minus 1th term, and when we will get those values n minus 1th x value in the previous term equation, we can substitute that in the previous equation. So this is then the iterative process. Now the first thing is that we have to get the value of xn from the last term. So how we can get it? We can just obtain the solution by back substitution. So by back substitution is like, for example, we have here ann xn. Here we are having the term ann xn is equal to bn, right? So we can just simply say that our last term xn will be equivalent to bn divided by ann. So this value can be substituted back in the n minus 1th term to obtain the solution of xn minus 1. So this back substitution can be continued till we get the solution of the x1. So this is the way or the algorithm which we follow to solve the linear equations in the basic Gauss. So in my next video, we will try to take an example on basic Gauss and we will solve that equation using the same procedure.